it. And that's how you solve all the world's problems. Welcome, everybody. How y'all doing? Welcome, welcome, welcome. Happy Thursday. Good morning, good evening, good afternoon, no matter where you're coming from. Hope you all are doing well. Let's go. Alrighty, folks. Let's get locked and loaded. We got a lot of Node to get into this evening. Lots of Node to get into. Super excited. All right, we had some folks get in here early. Leaving the virtual apples. I saw that. Thank you. Gordito. Thank you for the 1 month. Thank you for the sub. I appreciate that. Hits Din. Hey, thank you for the 4 months. Appreciate you. Bugaboo with the 7 months in a row. What's up, fam? How you doing? Pogo with the 5 months. Thank you so much. Diabolical. We got it. We caught it. Let's go. Let's go. Let's go. We got it, folks. 52 folks. Part of the raid. We hit it. I asked for it. We got it. Let's go. I'm so pumped. That's amazing. Let's go. If you all have time before this stream, long term, Triple OG, Dab Squad, or Dab Gang, sorry, is streaming right before this stream. Go hang out, get your questions answered, and then come over with the raid. Whew. Whew. 52, let's go. Let's go. Dabbing on the haters. Love it, I love it, I love it, I love it. Let's go. Pie with the 300 bits, thank you so much. Bobby Lynn with the gifted sub, thank you. Hey, thank you so much, everybody. I appreciate the support. Thank you for showing up. Got a lot of fun stuff to get into today. Hey, Kuro with the prime, thank you so much. Appreciate the support. Thank you so much. Alrighty, folks. We got some stuff to get into this evening. We're going deeper. We got some topics that we got to talk about. Topics that, like, people that have been running JavaScript for a long time, they don't even know. All right? They don't even know. Some of the topics we're about to cover tonight are going to make you stand out when it comes time to start applying. Whoo, Izzy with the 100 bits. Thank you so much. Thank you so much. Appreciate it. So, we got some fun stuff to get to. We're reinforcing some of the concepts from Tuesday. We're going over more concepts tonight. We're really just trying to walk away with a rough idea of like what JavaScript really is doing underneath the hood. And then what is it doing in the browser? What is it doing via Node? And then we're going to start practicing some backend. And the end goal, hopefully, is that we get some time to work on code together. Cool. Let's go, everybody. Let's get in. I'm going to go to Little Leon. We're gonna try to get into this real quick. Alrighty. So, got a little bit of. Let me chill the music here. Hey, what? Izzy with the 100 bits, thank you. Old Coder Chick with the 300 bits, thank you. Boom Kingston with the 1500 bits, thank you. I appreciate the support. Thank you for getting the hype train going. Subtoast, thank you for the 5 months. This is wild. This is wild. This is wild. Thank you, everybody. I appreciate the support. Do you have a CS degree? Hell no. Yeah, I think you can gift it specifically, but if the random ones are, like if you just do a regular gift, it is random, yeah. What did I major in before? I was doing biological anthropology. I studied hormones. I was doing a lot of research on testosterone, estradiol. I was looking at duck hormones. It was a lot of fun stuff. And then, yeah, dropped out to start a company. Left Yale and ran that company for a while. Yeah. Yeah, there's a lot of wild stuff. So my background's like a hard science biology background, yeah. But wanted to start a company, had to understand what was happening to build our software, and I started to teach myself to code. Oops, my bad, bro. Thank you for the 500 bits. I appreciate you. Alrighty. Let's keep it moving, folks. We got some 100 devs. There was a question of the day. We've been slacking on the question of the day recently. So I want a good answer to the question of the day today. So the question of the day today was, would you rather be the funniest or the smartest person in the world? Funniest or smartest person in the world? Bobby Lynn, hey, thank you for the $10 going to the buying in a company fund. This is good. This is a good one. This is split. Funniest, smartest. All right, this is a good mix. I thought it'd be leaning one more. I think funniest is winning out. I think funniest winning out. As soon as I said it, now smart's trying to turn the tide. Go ahead. Just say fun or smart. That's all you got to do. Let's see. You'd be good at coding, but not at friends. I don't know. I think if I'm smart enough, maybe I can if you're the smartest person, maybe you can even if you you'd be able to figure out humans. I don't know. I think I'm going to go, as long as this isn't as long as this isn't a genie trap, how genies kind of trick you. Oh, you didn't think about this one thing. The reason you're the funniest is because you have something, I don't know, that makes people laugh at you. I don't know, right? As long as this isn't a genie trap, then I'm going to say smartest. I feel like I want to be the smartest person. Funny is such a good one, though, too. If you were legitimately the funniest person in the world, that's very lucrative, too. I don't know. I'm going to go with smartest. Alrighty, folks. Thank you for sharing. It's always cool to see these. This is one of my favorite parts of stream. I just like to see what way y'all lean. And it's funny because I get to see people's answers over time. So I feel like I get to know some of your personalities just based off of these first questions of the day. So thank you for sharing them. Count the shells. Alrighty. Let's keep it moving. All right, so today we're talking more about how JavaScript has all been lies. We're talking about something called the call stack and the task queue. We're getting into some fun event loop stuff. Then we're talking Node. We're going to start building some very simple backend applications. And for homework, you got some videos to watch. You got some code to clean up. And you got some building to do. So the idea here is to get into this. Get into some hard topics, but hopefully explain them in a way that makes sense and have a good idea of what we want going forward. Alrighty, questions before we get started. I always like to leave a little room for questions. Is Java useless? No, Java's not useless. Java is a tool that's in your tool belt, and there are scenarios where it's a good tool to use. Any questions before we get into it? When will we finish the backend 1 week? No, it's probably gonna be a couple. Let's see. We're at March now. End of April is when we'll be pretty good with the backend and have built a lot of stuff. Adil, thank you for the hydration. Cheers to you. Thank you so much. Can you explain Node versus NPM? So we're going to actually do a lot of this digging today about that, but Node is just a place to run JavaScript. Let's think about that. It's just a place where your JavaScript runs. And that place where it runs, Node gives JavaScript access to a bunch of stuff. And it gives it access to a bunch of stuff so that JavaScript can do more powerful things when it's running in this Node environment. And one of the things that JavaScript gets access to are something called modules. And so modules are just lists of functions. That's all they are, it's just lists of functions. And so when JavaScript is running in the Node environment, it gets access to these functions that are pre-built so we can do a lot of heavy lifting and a lot of fun stuff. And then what people said is, you know what, we want to build our own modules or collections of modules that we call packages. And then NPM is just a registry for those millions of packages. I think it's almost 2 million custom packages that you can use. So we're going to definitely get into that a little bit more deeper tonight. But that's the idea, is that like we understood that JavaScript isn't just by itself. It's running in some sort of environment, right? And in that environment, we want to make sure that it gets access to some cool stuff, and NPM is how we can get access to some cool stuff. Alrighty. Will we have another week for break to catch up? Probably towards the end of program. Yeah. We're going to have a week for you to have like a solid week to just work on your 100 hours project. 8 Bearings Photo, thank you for redeeming the Pokemon card. We will redeem them live today. So once we take a break, we come back from break. I'll queue them up. I didn't queue them up last time. So when we take a break, I'll queue them up. And then when we come back from break, we will do the raffle for the Pokemon cards. Because I got to pull up the list and everything. Cool. What do you think about a DevOps career? It can be okay. I think it's a lot harder to, like, for me, from my experience of helping hundreds of folks get into jobs and helping dozens of folks get into DevOps, it was slightly harder, and their career growth has been lower. So when I look at my students that went the DevOps route and my students that went the web development route, the ones that went the web development route almost universally make more money. So unless you really like it, for me, my goal is to get people jobs that are high growth and to make the most money possible, typically is what I'm shooting for. And so I've seen the most growth and the most like opportunity with focusing on web development. Now, I do have some students that just preferred DevOps and went that route, but it hasn't been equal their growth. And so that's anecdotal. That's my experience of helping hundreds of folks get jobs. But yeah, so that's why I don't push people towards that track. Alrighty. Let's keep moving, folks. We got some stuff to get into. Glad you're all here. Let's have some fun. Prep class, Friday. Don't forget. So tomorrow, we're back live. We'll be meeting on Remo. We're going to be practicing prep. The thing that you're going to need to start practicing every day so you can slam dunk, 360 slam dunk your interviews. All right. Office hours will be on Sunday, 1 p.m. Eastern time. Cool. Don't forget, this week we're starting our networking. You owe me one coffee chat this week. Just one coffee chat. Just one itty bitty coffee chat. One coffee chat this week. How prepared will we be for blockchain dev after this class? I mean, you'll know how to code, but it won't have any of the stuff that that follow. It won't have any of the stuff that you would need that's like special tooling for blockchain. Yeah. Alrighty. Remember, you should be using the sheet as you're doing your networking. For those that have been adventurous and started building out their hit list, use the sheet. If you're new and haven't grabbed the checklist yet and you haven't done your professional stuff, grab the checklist. You should be filling out the checklist. Your goal should be to get that checklist done as soon as possible so that all those profiles can start marinating and folks can start finding you on the interwebs. A lot of folks have already been saying, like, I have people reaching out to me left and right saying, Leon, like, I'm already getting recruiters hitting me up. I'm already getting like interviews because they did the checklist. Do the checklist. It's easy. It starts marinating and you'll have some inbound stuff coming in as well. Rufio said, how do we know what companies we should be looking to work at? Companies that have entry-level software engineering roles are where you're looking for. You're going to build a hit list of every single one that you can find, and then you're going to narrow it down to like 60 that you really want to kind of go recommendation through. So we're not really there yet where we're going to start really kind of cranking on that process, but we will get there soon, and we'll have lots of classes on how to do that effectively. Do you recommend doing a startup? No, not unless you have money in the bank. If you have a good runway, like you got 6 months of runway in the bank, go for it. You can learn a lot, but if you don't have the funds to sustain yourself, you're in for a trip. All right. Remember, we should be pushing every day. You should be pushing every day. You should be doing a code challenge every day. You should be pushing code every day. Recruiters love those green squares. They do. And it's so easy. Just do a 7Q. Do an 8Q if you're not feeling good that day. And then push it to GitHub. Push every day. It keeps the recruiters not away, but running to you because they love those green squares. If you didn't submit on Tuesday, please submit your work. I want your work. Submit your checklist, your 100 hours project, Code Wars. I'm looking at them this weekend. I want to see where folks are kind of headed. Make sure we're all on the right path here. So please get that in if you haven't gotten it in on Tuesday. Remember, you should be prepping the bank. Exclamation point, the bank here in chat. Exclamation point, the bank here in chat. You should be doing this bank, and all the questions that you're answering should be going into some sort of spaced repetition tool. Every day, you should be doing some sort of coding challenge and reviewing the bank. Every day. No skipsies. No waitsies. No chunking on a Saturday. Every day. If you only got 10 minutes, squeeze in 10 minutes of the bank spaced repetition on Anki. Every day. Squeeze it in. Spaced repetition works. You want to be in these interviews. Lean, mean interviewing machines, and that comes from preparation, and that preparation starts now. All right. Now, a lot of the stuff that's in this class is stuff that I have garnered from some really smart folks on the internet. And in fact, your homework is to watch these two videos. Philip Roberts gave an amazing talk on like what's happening underneath the hood with JavaScript. And Jake Archibald gave like the talk on what the event loop is and how it works. I am summarizing a lot of stuff that came from these videos, or I'm trying to talk about it in a way that I think is less confusing. Right? And so for me, I think these are like the must watch videos. Like if you are adventuring to learn JavaScript, you're adventuring to learn Node, these are two must watch, cannot be skipped videos. And so they are part of your homework this week. If you need a link to submit stuff, the link is actually right there in the slides. Whenever you see those blue links, those blue things are, those are links. So you can just click on the slides there and grab it. It's also, the link was in the Follow Along Materials channel on Discord. So shout out to these two folks. Hold it down. I've learned a lot, and you're going to see a lot of kind of common themes tonight from these two videos. Alrighty. We're getting to the back end, folks. We're going to back that stack up. I forget who said it. Does anybody remember who said it in chat? Back that stack up. I love it. We're going to back that stack up. But before we get to the back end, I want to make sure that we kind of review some of the concepts from last class. We feel comfortable with those concepts, and we build on top of them. We're going to build on top of those concepts, review some more nitty-gritty details, and then we're going to start building. Okay? Alrighty. Chat. JavaScript is single-threaded. What the heck does that mean? What does JavaScript being single-threaded mean? Single-threaded. What does that mean? Yeah, one at a time. One task at a time. One operation at a time. Got my microplastics tonight. Hey. Turn up with the water. Or if you're from Philly, the water. Alrighty. Yeah. One process at a time. It can only do one thing at a time. JavaScript is single-threaded. It is not multi-threaded, where we can have multiple processes running at the same time. One process at a time. Now, that makes our code synchronous. And so if our code is only able to do one thing at a time, how do we do all the stuff that we do normally? How do we like make an API request but like click on stuff? How do we like scroll after we click? How do we do all of this stuff when JavaScript really should be blocking? If it's single-threaded and can only do one thing at a time, right? Things should block. How do things not block, right? So that's the big question. If JavaScript is single-threaded, it should only be able to do one thing at a time. How are we able to do all these wonderful things that should be blocking? And as we talked about it last class, it's due to the environment. right? The environment in which JavaScript is running, right? And when I talk about environment, I'm not talking about the earth. I'm talking about the best GIF I've ever found. I'm talking about this, baby, right here. This is what I'm talking about. When I say JavaScript can do blocking stuff because of its environment, this is what I want you to think of, right? JavaScript is running in a browser. This changes everything. JavaScript is the language, right? But that language is running in a special environment. And that special environment is the browser. And when our JavaScript is running in the browser gives it access to a bunch of goodies, right? And some of the biggest things it gives access to are a bunch of web APIs, right? There are a bunch of web APIs that JavaScript is getting access to when it's running in the browser. Izzy said, where do those APIs live? In the browser's code or the internet? In the browser. You got to think the browser is a program that's running on your computer, right? Or maybe your mobile phone, right? It's a program, just like Microsoft Word is a program, or Photoshop would be a program, or a video game would be a program, right? A browser is just a program, and we're running JavaScript inside of that program. And so that program gives JavaScript access to a bunch of stuff. And the stuff that we talked a lot about were these web APIs. And so we saw that JavaScript got access to a common API called the DOM. We learned pretty quickly that JavaScript actually doesn't have access to the DOM. Like JavaScript, the language itself, does not have the word document.query selector. It doesn't have these other things that we learned about a little bit later on. So the things that we thought we were writing that were JavaScript this whole time weren't actually JavaScript. What the fuck? What? Vance, exactly. Yeah. So I remember, like, this was the biggest thing for me. Like, when I figured this out, my mind exploded. That all these things I thought were JavaScript and they weren't JavaScript. It was really web APIs, and it always has been. All right. So the things I thought were JavaScript were really just web APIs. And the reason I had access to those web APIs is because I was running my JavaScript in the browser. Did you make this meme? Yes, I made the meme. Specifically for this class, I made the meme. I had to make the meme. JavaScript was the cake. I never thought JavaScript would go behind my back like this. I thought we were really getting along. Just when you, this is the theme of the night. Just when you thought you were going to go get, you went and got. We all got. We thought we came here to get, we got. What happens when languages other than JavaScript try to access the web APIs? So this is a really interesting concept. Since these web APIs are not JavaScript themselves, technically we could write a language that could access them as well, right? So we could figure out how to make Python be able to access the DOM. We could figure out how to make Ruby access the DOM directly. Now, the browsers would have to play along, right? The browsers would have to play along, like they would have to be able to expose the API to that language, and that language would need to like figure out how to latch into it. So technically this could happen, and there are like pet projects where people have kind of made this happen, but you would need both like the language and the browser to play along so that you could attach into these things. Yeah. Izzy script. And in fact, if you like go through the history of JavaScript, there's been a lot of weird shenanigans that happen because this is true. Neject, hey, thank you for the 3 months. I appreciate that. Thank you for being here. Hope you're doing well. All right. So yeah, JavaScript can do a lot of things that we would consider blocking because it's handing off all of that blocking stuff to some web APIs. Right? It's handing that stuff off to some web APIs. And if we're handing off all this blocking stuff to web APIs, then we got to get really good at handling the responses that come back from those web APIs. All right? If we are sending all of our stuff off to these web APIs, right? We got to figure out how to handle the responses that come back. And we saw 3 different ways, right? We saw callbacks, we saw promises, and we saw async await, which was some syntactical sugar on top, right? So we saw 3 different ways of kind of handling those requests as they come back. So let's quickly jump through the old school way. The old school way of kind of making sure that we could run some of this asynchronous code and wait for this asynchronous code to come back. The original way was callbacks, right? You have this idea that in JavaScript, you can have a function that takes in another function as an argument. And whenever you have a function that takes in another function as an argument, what do we call that, chat? What do we call a function that can take in another function as an argument? What do we call that? Don't look at the slides. Chat goes wild. Yeah, it's a higher order function. Whenever you have a function that takes in another function, we're talking about a higher order function, folks, here. Something cool about JavaScript. Now, we've seen this idea of higher order functions a bazillion times. Whenever you've done an event listener, right? I forgot to cover the slide with my hand, yeah. Whenever you have made an event listener, you had a function, right? We had this event listener, which clearly we can see is a function, parentheses, open and close. And then we passed in a function. Since this is a function that's taking a function as an argument, that makes add event listener a what? That makes add event listener a what? Chat, what's add event listener? It's a what? Higher order function, exactly. Alrighty. Now, the click event ran a function. Once the click was heard, once the Smurf heard the click, it ran a function. And the function it ran, we call a callback, right? So the idea here is that a callback is a function that has been passed in as an argument. So higher order function is a function that takes in a function. The function that it took in is the callback. Okay. Now, it's not really like a thing. It's just a convention that we have in JavaScript. And so it's a term that might be wishy-washy depending on who you're talking to or where they're coming from. But the idea here is that a function that takes in a function is a higher order function. And the function that you passed in as an argument, we're going to call a callback. Okay. Alrighty. Now, the last important thing to remember about callbacks, right, is that a callback fires when an async task or another function is done. So when that asynchronous task is done, we have that callback that is firing, right? That's something to keep in mind. And so what we saw here was to kind of do this the old school way, we could have a bunch of nested calls to a web API, right? Set timeout. Each of these are web APIs, right? And we're nesting them inside of each other. So we're nesting callbacks so that after this one completes, then this one would run. And after this one completes, then this one would run. And so we were using callbacks here to handle, all right, when that first asynchronous task is done, run this next one. And when this asynchronous task is done, run this one. But we wind up with the pyramid of doom. We wind up in callback hell. Callback hell. So to get us out of callback hell, when ES8 updated, we got something really interesting. Rick James, hey, oh boy, whew. I got a slide for you later. Thank you for this sub. I appreciate you. Thank you for being here. What did JavaScript give us to save us from callback hell? Chat, what did they give us? Hey, they gave us a promise. They gave us a promise of a better future. Sorry, promises were ES6. Async Await was ES8. Yeah, with ES6, they gave us a promise of a better future. They said, what if there was a more readable way to handle asynchronous code? And they said, all right, let's make a promise. A promise is really just an object, folks. It's just an object that may have a value in the future. That's all it is. It's an object. We've dealt with it. Last class, we saw that it could be pending, fulfilled, rejected, but it was still just an object at the end of the day. And that object came with some really good methods. And one of the methods that it came with was then. Then is a method that will run, right? Then is a method that will run when our promise resolves. When our promise finishes running, then the then fires. I'm glad I didn't learn JS in 2015. Right? So, when the promise resolves, when it's finished, the then method fires. And the cool thing is when it fires, the value gets passed through it. The value that we got from that object gets passed in as the argument, right? So what this leads to is something that we've all seen before, right? We've all seen this promise pattern before, these promises in action. We've seen them when we've used fetch. Fetch is a web API that returns a what, chat? What does a fetch return? What does a fetch return? Yeah. It returns a promise. Cool. So when that promise resolves, what runs, chat? When the promise resolves, what's going to run? When that promise resolves, what runs? Then, yes. So the value, remember, the value gets passed in when the promise resolves as well. So the value gets passed in through res, short for response. And so the first thing we're doing is we're mapping our response to JSON, because the response that comes back from this API is probably going to have a lot of stuff, like all the headers and other stuff that might come back with that request. We don't know what's coming back, right? A bunch of stuff could come back, right? And so the first thing we want to do is we want to map that response, right? Right? We want to map that response to JSON because JSON is something we're comfortable with. It's just an object notation. We can parse it. We can use it. We can do what we want with it. So the promise resolves. The then fires. Then the next then fires. And we take that JSON data that we have now, and we're just console logging it. Cool. And then we're done. So when the promise resolves, right, the then fires, and the value gets passed in through then. Now, if something had gone wrong, what if our fetch, our web API that returns a promise, what if it, like, the dog CEO, imagine the day, I hope it never happens. Imagine the day the dog CEO API is down, right? And so the promise never resolves. The promise is rejected. I have something weird on my face. I don't know what it is. I have like a hair or something, right? The promise is rejected. What happens, chat? The dog CEO API is down, right? Dog CEO API is down. The promise never resolves. In fact, it's rejected. That's when the catch fires. So when the promise resolves and is fulfilled, we get the then. But if for whatever reason it is rejected, we get the catch. It will catch an error. Cool. Let's keep it moving, folks. Remember, fetch returns a promise. And the cool thing is, fetch returns a promise, But so do most of the web APIs that we get when we run JavaScript in the browser. So if you could start to figure out how to handle these promises, you can do a lot of fun stuff. All right. Here was the code that we eventually built when it came to promises. We had our house one, right? We had our house one, and then we had our house two, and we had our house three. And the cool thing is that each one of those house functions returns a what? What do each of our functions here return, chat? Yeah, each of these are returning a promise. Exactly. We can see that they're all promises. And like I said last class, I rarely build promises. Like I'm rarely like building my own. I'm almost universally always consuming them. So this is kind of like one of the rare examples where you see me build a promise, but I'm often consuming them a lot. So I say I consume them way, way, way more than I actually build them. But this was an example. All of our promises are great. And we're using the then syntax to chain all of the promises as they're getting resolved. So we run the house one. It takes a second, and then the promise resolves. The then is fired, and we console log paper delivered to house one. Then the next then is triggered. House two runs. What we wind up having is once this promise resolves, this then fires, and data gets console logged, and we wind up seeing paper delivered to house two in the console log. Then the next then runs. We run the house three. When this promise resolves, we see that this then fires. That data then gets console logged, and we see paper delivered to house three finally in the console log. If at any point any of these had errored, we would have seen the catch fire. Mark said, can we have a little sugar, please? Can we get a little sugar? There's a little bit of sugar. There's a little bit of sugar. Alrighty. So the reason why we're asking for a little sugar is that this chaining don't read too good. Like it works. Like that works. But I don't know. It doesn't look good. Right? Like it works. Doesn't look good though. So with ES8, the developers heeded our call of wanting our asynchronous code to look synchronous. And with ES8, we got Async Await. Okay. With Async Await, we got a nice new syntactical sugar, right? Some nice new syntactical sugar that just is a way to handle our async responses. And it still technically promises under the hood. It's just syntactical sugar on top of those promises, just to hopefully make our code easier to write and understand, right? And the key thing here is that inside of an async function, the await will wait for the completion of said function, right? See a lot of confusion here about the ES stuff. So you have to think about that there's actually a base like language specification called ECMAScript, and JavaScript is an implementation of that specification. What? So ECMAScript is like the base language, right? And JavaScript implements all the stuff from that standard body, right? Technically, you can make your own language that has ECMAScript as a base and call it whatever you want, right? And so JavaScript is an implementation is a weird word to use here. It is an implementation of ECMAScript. And the cool thing is that ECMAScript is actually the thing that's getting updated. So this specification is the thing that's actually getting updated. And as it updates, the JavaScript that we use is getting updated as well. And so the biggest thing that happened was in 2015, ECMAScript had these like really big changes. And we call those big changes that started in 2015 and carried over into 2016 ES6. So we have been writing in this almost entire program. We have been writing all of the stuff that came from ECMAScript 2015 forward. There were some things that we used really early on that technically would have been like a contradiction to the newer syntax. And chat, what was that? What is one of the things that we used early on that I said, like, we probably won't do this all the time going forward? Anybody remember what that was? Yeah, internal student. Yeah, it was var. I was like, hey, like, be careful. This var thing kind of changed with ES6, right? And so we got let, and we got const, and we got these newer things when ES6 rolled out. Now, they've been on a tear. They've been adding all this new stuff. And then in 2018, we got we got this async await syntax. We got this async await with ES 2018 or ES8. We got this lovely async await syntax. Cheese, please. Thank you for the hydration. Cheers to you. Let's go. Cool. So, the code that we just wrote a few moments ago now looks a lot better. All this stuff is the same up top. All of our functions are returning promises. But look at this syntax. Look at this syntax. Delicious. Look at it. Just look at it. Oh. Whew. It turns what is our asynchronous code now looks synchronous. It looks like I'm just reading this down the line and it just works, right? I don't have to do a callback where like I'm nesting stuff and I wind up with the pyramid of doom and land squarely in callback hell. I don't have to worry about chaining my thens in a long like promise chain then thing conglomeration. I slap on a nice async at the front of my function, and then I get access to this lovely await keyword. And I can write my asynchronous code as though it looks synchronous. Whew. That's sexy. All right. This code is OnlyFans content. I am confused. So what about then? We don't need it anymore. When you use the async await syntax, you don't need to chain. The await is doing the same thing that the then was doing, basically. Boom. All right. The complaint that I always get is like, I need something real. Leon, you're talking about newspapers being delivered. And the cool thing is that we can really use this syntax pretty practically out the gate when we build our APIs request, right? So here is an async await API request. We throw the nice async on the front, and then we can await our fetch, right? So once the fetch resolves, all of that wonderful value that came back through from the promise, right, is stored in res. Because remember, this fetch is going to return a what? This fetch is going to return a what? A promise, exactly. This fetch is returning a promise. And so that means that async await is really just what underneath the hood? It's just a promise. Async await is just a promise with some syntactical sugar on top. So we don't need the then syntax, or it looks a little bit more readable. We're not worried about chaining, right? That's all it is. GZ, yes. Yep. Our asynchronous code now works like synchronous code. So if we ran this code from here, we would see house 1, then house 2, then house 3 get printed to the console. And so it would just wait. We don't need callbacks to wait. We don't need like the promise then chaining to wait. It just runs. Dev Henry asked a great question. Dev Henry said, hey, how do I catch an error? And so this is part of the homework that I asked you to do. Part of the homework that I asked you to do was to introduce a try and a catch, right? And so tries and catches are the way that you can catch errors. And so I still would like you to do that for homework. If you haven't done that for homework, I want you to try and write this API request with a try and catch, which means you're going to need to use a resource, right? You want to use a resource like the MDN to see how that's implemented, and then we'll go over it together on Sunday because I want you to try it for homework. Or today, when we get to our Remo class time, maybe the folks at your table can try that out first, so you don't have to do it on your own. Cool. All right, so we're building up to something here, folks. I want to use a web API, and the web API I'm going to use. I forgot to turn my Steam notifications off. Sorry, 1 second. I had Steam running. I'm like getting messages. The web API that I want to use is set timeout. Not JavaScript. The web API I want to use is set timeout. This blew my mind. Like literally, like I know I said this a couple times, but like literally my mind broke in half when I realized, right? When I realized that set timeout and set interval actually aren't JavaScript. Like if you read the specification, there is no such thing as set timeout. There's no such thing as set interval. Those are web APIs that are exposed to JavaScript based on where JavaScript is running. I want to speak to the manager. Yes, set timeout, set interval are not part of JavaScript. What? Why does nobody ever talk about this? This is like the biggest thing. I just don't get why this isn't taught really early on. I probably wrote JavaScript for like years before I knew this was a thing. And so this is why I think this is some important stuff. A lot of boot camps really don't cover this. They just don't. I've seen a lot of engineers that don't know about the actual environment that JavaScript is running in. Right? A lot of boot camps, they don't even use the newer syntax, right? Gotta be careful. We're using the newer ES6 plus syntax. We're understanding that the JavaScript is running in an environment. And when it's running in an environment, it gets access, right? It gets access to some special stuff. A bunch of web APIs like fetch, that was a web API. Set timeout, set interval, web API. The DOM, web API. We're lucky, though, that most of the environments and where we're going to run our JavaScript actually come with these things. Like all the major browsers have it and Node has it as well. All right. So here is where we got to last time. And I said we'd come back on Thursday. So I want to talk about this, and then we're going to take our first break so that we can come back fresh. All right. Here's some code. I want to run this code. So I'm going to open up my async practice. If you need the code for today, you should join our Discord, !Discord in chat. Once you agree to the rules, you will see a follow along materials channel that will have all of the material that you need for today, including the starter code that we're about to run. So I'm going to go ahead and go to my async practice. And down here, I have this code. I forget which one it was, sorry. Here we go. Alrighty. Here's this code. It's code 3. Gonna save it. And if we look at code 3, we have a console log, right? House 1 gets console logged. Then house 2 gets console logged. And then house 3, we got a console log in here as well. And so what we're seeing here is we have house 1 that's going to get called. And then right after it, house 2 will be called. And we have a lovely, what is technically house 3, chat? What is house 3, chat? What is this lovely house 3? It's a callback. And if house 3 is a callback, then house 2 is a what? Yeah, it's a higher order function. All right, so what we expect to have happen is that house 1 should run like normal, and then house 2 should run, and then the cool thing is that once this callback is done, right? Once this callback is done, then house 3 would run, right? Because we're passing in house 3 into the callback. And so what happens is when this set timeout is done, it prints house 2 to the console, and then it runs house 3, because that's what the callback is. All right. So let's go ahead and save this up. Let's go back to our browser. I'm going to open this in the browser. I'm going to look at my console. And I refresh. Cool. So when I have the callback, right? When I have the callback, it waits. Right? When I have the callback, it waits. I had house 1 that got logged, then house 2 logged, and then because the callback fired, house 3 ran. So the code that we have here is a little different. Chat, how is this code a little different? How is this code a little different? What's different about this code and the code that I just showed you? Yeah, exactly, chat. There's no callback here. There's no callback here. So is there anything that is stopping house 3 from running automagically? Fox, hey, thank you for the hydration. Cheers to you. Thank you. No, there's nothing that's stopping this house 3 from running. Remember, JavaScript synchronous, boom, 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 wants to run. So since there is no callback, we're going to see something funky. We're going to see something funky. Let me comment out this code. I'm going to go up to code 2. All right, code 2 is up here. Code 2 is the code we're looking at. No callback. No callback. Let's go back and run. Boom. We saw that house 1 ran, then house 3 ran, and then house 2. And what we talked about was that since we know that set timeout is a web API, right? Since we know that set timeout is a web API, JavaScript, right, is kind of handing this off. It's saying, hey, web API, handle this set, like you do this set timeout thing. Okay? You do this set timeout thing. And when you're done, let me know. So the set timeout goes and does its thing. And then when it's done, right? When it's done, then we find out. So the thing here is that we expect this to do what we just saw, right? We expect this to run. We expect the web API to go do its thing. We expect this to run almost instantly. And then we expect house 2 to eventually run third. Okay? Now, the interesting thing here is, all right, we understand that there is a delay here, right? And so that's why we're waiting. We understand, all right, well, there's a 3-second delay here. That's 3,000 milliseconds. That's 3 seconds, right? We expect that this would take some time. We expect it's going to take those 3 seconds and then kind of let us know what happened. But something really odd is here. When I change that from 3,000 to 0, so there's no delay. By today, there is no delay, right? There's no delay, but we are still using the web API. So we're still using the web API, but there's no delay. Let's see what happens now. So I'm going to go back. going to change this from 3,000 to 0. And I'm going to save. We come back. We run it. Same result. Still 1, 3, 2. 1, 3, 2. There's no delay in our code. Yet, it's still coming out after house 3. And so the reason why this is happening is the event loop. So, you thought you came here to get. You just got. And now we're going to take a break. We're going to come back so we can learn to get and not get got. We're going to learn the secrets of the event loop and how it's actually working and what it's doing underneath the hood so that we don't get got. We came here to get, folks, not to get got. All right. Let's go ahead and take a 5-minute break. We're going to go ahead and take a 5-minute break. And when we come back, we're going to get into this event loop and what the heck does it actually mean. All right, I'm going to put a smart timer on. We got 5 minutes on the clock here, folks. Enjoy your break. If you're able to, get up, hydrate, do what you got to do. Put some chill tunes on for us while we wait. Hey, feel the vibes. Oh, window scans. This is one of my favorite clips of Always Sunny in Philadelphia, too. Digital Fendi with the hydration. Cheers to you. Internal student, that's probably where I picked it up. I'm pretty sure that's where I got it from. Can we start rigging YOLOs? I want my 80K back. We'll be going over to Remo tonight. Yes. I'm expecting that the next portion takes us about an hour to get through. Maybe a little bit less, and then we're jumping over to Remo. Oh, yeah, let me queue up the Pokemon raffle. I'm going to get the raffle up. We're also going to run some ads real quick, folks. So, sorry. Just make sure that new folks can jump into the stream. I'm going to run a 3-minute ad break. We'll be back when the ad... Actually, we'll do a 1 minute 30. All right, pulling up this the channel points. Trying to pull up the request queue. All right, we got some Pokemon cards here. All right. I think we have Chomp today and 8 Bearings Photo that need their cards today. Alrighty, folks. If you haven't able to, please get up, hydrate, do what you need to do. I'm gonna pull up the console here real quick. And we need the list. We need the Pokemon card list. I think I have it up already. Yes. Alrighty. Just send out the Pokemon card list here. Sorry, folks, I'm not looking at chat at the moment. There we go. All right, we got it going. I got the list. We got 75. All right, we got 75 on the list right now. We're in a good spot. All right. Boom. Alrighty. What is going to be on Remo tonight? We're going to be working on our first Node apps together. Ooh, Izzy with the Pokemon card redemption too. All right, so we got a couple tonight. Got a couple to do. The link is is in the slide. So the last slide will have the link. What's the Pokemon raffle? If you have 50k channel points, which you get for free just by being here, you can use them to get a Pokemon card that I will send you in the mail. And so people have been using their points to get them. I have a bunch of stuff that's gone out. So yeah. Can we bet real quick? We gotta save the bets. Maybe once a week. I gotta slow down this accumulation of channel points here. What? Alyssa, that's wild. XD, hey, thank you for the Prime. I appreciate that. Thank you so much. Thank you for being here. I got mine yesterday. I'm pumped. I am now vaccinated. Still got to get my second one, but I got the first one at least. Aw, blah. Day 30 and 31 material are the same. I recommend just using the day 31 just so that it's in that folder already. Alrighty, folks, 3 seconds left. Come on back. Alrighty, folks, hope you had a good break. As promised, we have 3 Pokemon raffles to do tonight. We have Chop, 8 Bearings Photo, and Izzy. So let me go ahead and pull up my console here. We're doing the raffle out of 75. Let's go ahead and do our math.seal. And then we're going to do our lovely math.random. And we're going to do that times 75. All right. Oh, we still have to do the mask raffle as well. So if you have subscribed to the newsletter, ! Newsletter in chat, there's always the goodies. Always the goodies come out in the newsletter first. And so if you open the newsletter on Tuesday, you had a shot at a sticker. You open the newsletter today, you had a shot at a lovely Learn with Leon mask. Yes, that's right, folks. A Learn with Leon mask was up for grabs in the newsletter today. Opening those newsletters pays off. That's all I got to say. All right. Electro. DM me app and I can just add you manually if you're having trouble. All right. This first one is for Chop. Chop, this is for your card. Alrighty. Let's go. 3, 2, 1. 62. All right. What do we got for 62? 62 is... Ooh, interviewers' questions. Nice. Interviewers' questions is coming your way, Chop. Let me go ahead and remove this. Well, one from the list here. Lovely interviewers' questions. That's going from a 2 to a 1. Nice. So we're going to run this back again. This is for 8 Bearings Photo. 8 Bearings Photo. Let's do this again. Still out of 75. Boom. 41. What do we got for 41? Ooh, Roserade GL. Nice. It's a good card. It's a pretty looking card. All right, Roserade GL coming your way. 8 Bearings Photo. Going to remove this from the list. Delete. All right. And then the last one is for Izzy. Izzy, this card's coming your way. Let's go ahead and run it one more time. Ooh, wrong one. Run it one more time. And this is out of 74 now. Alrighty, Izzy. Here we go. 3, 2, 1. 48. Let's see what we got. Ooh, we got a Twins. A nice card. Twins card. There we go. A nice Twins coming your way. Let's go ahead and move this to 1. Wait, was that 40? It was 48, right? What was it? 48. Yeah, it was twins. Twins coming your way. Going to change that from a 2 to a 1. Woo! Thank you for playing, everybody. All right, so that's all the Pokemon cards. We also have the raffle for the mask. And at class start, remember I asked you to open it before class. At class start, we had 92 folks. So we're going to do this again, but with 92 that had opened it already. So we're going to go ahead and say, well, 92 that people have opened it and like filled out the mask link. Way more people are opening it and just not filling out the link, but it's out of 92. All right. So once again, I don't have this like set up to where I don't want to like dox anyone or show their information online. So I got to figure out a way to like show this live, but for right now, we are going to do it here and I'm going to tell you who it is. Alrighty. 3, 2, 1, 8. And you're going to hear me click. You're already going to hear me click and I'm going to be able to say who the 8th was. Didn't actually click on it. Here we go. All right, we're at 1. Here's 2, 3, 4, 5, 6, 7, and 8. Wilson F. Baby. Wilson F. Baby. You just won yourself a mask raffle. Go ahead and send me your details in a Discord DM, and I will have the mask coming your way. Wilson F. Baby. Woo! Congrats. All right, I think that's caught up on all the raffles and fun stuff. Let's get back into getting got. Sometimes I just like dig the music. Bombo, give it a refresh and maybe dial down the quality settings. Might be helpful. Alrighty, folks. Let's talk about the event loop. Before we can get into the event loop, did the swag bags go out yet? No, not yet. I just got the last of the stuff in. So now it's just me having a day to go to the post office. So probably Monday is when I'm going to say all this stuff is going out, and I'll give people like tracking numbers if they need it and things like that. So I think Monday will be the day everything goes out because I finally have everything. I got the mask, the stickers, the fun stuff, and so I believe on Monday everything will go out because I can go to the post office then. And the Microsoft stuff should have already gone out. And if you redeemed anything on stream, that all went out as well. How do you know if the newsletter has been opened? I just get the analytics that tell me. Yeah. Basically, when you open an email, they put like an image in the email. Like one way. Let's imagine this is one way you can do it. If you put an image in your email, remember that image is not like in the email. That image is getting requested from a server, right? So I know that you opened the email because you tried to load that image, and so if you try to load that image, that request has to go to my server, and so I get all your stuff. I get who it was. I get like. I get where it was coming from. I get all your goodies, right? Just because you opened the email and you tried to request that image, right? So that's one way you could do it. What if you use something to prevent picture loads? Yeah, there are a bunch of like anti-tracking plugins that you can use that will stop that from happening. But I think a lot of the like if you're not using if you're using like a off-the-shelf email provider, they're probably going to stop you from like doing that. That's how they make some of their money. All right. So before we can get into the event loop and really talking about how the event loop works, we need to learn some data structures. And all data structures are just ways that we can organize data. Like when it comes to data structures and algorithms is something that you could do a whole class in university on. It's something that we're going to have a couple classes during the end of program at, because it really helps you when it comes to interviewing. And so a lot of people just grind out data structures and algorithms because it's really useful for interviews. But for now, we're just going to learn some practical uses of these types of structures for our data. But it's really just a way of like organizing stuff. That's all I want you to think about right now. So we're just organizing some data. And so there's two big ways that we need to organize data tonight. And the first way is a queue. Okay. A queue is just like a stack of Frisbees or a actual line that you stand in. And what I mean by this is that the first person into the queue is the first person out of the queue. If I have a bunch of Frisbees that you like, let's say everyone in chat, throw me a Frisbee. All right. Everyone go ahead and throw me a Frisbee. All right. I grabbed the first Frisbee. Somebody, you got to type Frisbee, ! Frisbee to throw a Frisbee. All right. I get my used Frisbee. Then I get Pritt's Frisbee. I get Brian's Frisbee. All these Frisbees are coming in. So now I got a stack of Frisbees. And I'm like trying to hold these Frisbees. And what I want to do is I want to start sending these Frisbees back. And so my hand is on the bottom with the Frisbees. And what I'm going to do is I'm going to start throwing the Frisbees from the bottom. So I'm throwing them back. All right, I'm throwing them back. So the first Frisbee I got was the first Frisbee that's going out from the bottom of the pile. Right? And so eventually I'll return all the Frisbees. Right? Eventually I'll return all the Frisbees and I'll have no Frisbees left in my queue. You could also think about it as like a line. I don't know. Back during the pre-pandemic days, it was Thirsty Thursdays. Maybe you're going to the club. And if you're not with me, you got to wait in line, right? So you're going and you get into the line and you're the first person in line. You will ideally be the first person let into the club, unless I show up, because I'm going right in. But if you were the first person in line and I didn't show up, then you're going right into the club first, right? You can think about queues as just like normal lines. The first person into the line, right, is the first person out of the line. Cool? It's just the way that we're going to organize stuff, right? We're going to organize people in a queue. We organize those Frisbees in a queue. These are data structures that we use all the time, right? Just because it's code or just because it's JavaScript doesn't mean like the idea of a queue changes. These are things that we know. We structure our lives around queues all the time, right? All right. What would a queue look like in JavaScript? Well, we can actually implement a queue pretty easily in JavaScript if we use an array. Now, if we have an array and we push stuff into an array, right? So here I'm going to push the number 2 into my array, and I'm going to push the number 5 into my array. So now I have an array that is 2 and 5, right? So I push stuff into it, right? And then I'm going to shift stuff off the front. So I pushed 2 in first, then I pushed in 5, and I'm going to shift off 2, and then I can shift off 5. So it's a very, very simple example of a queue. Just like the first person in line would be the first person out, since I pushed 2 in first, 2 will be the first thing to come out when I unshift it. When I shift it. All right. Alrighty. Printers use queues? Yeah, exactly. The first print they get is the first thing that comes out the printer. It's a queue. All right. The other data structure we need to know tonight is a stack. Okay? The way I like to think about stacks are like pancakes. All right? Stacks are like pancakes. When you make pancakes, if you're not a monster, you put your pancake, like you're making pancakes, you put the pancake onto the plate. Then you keep making more pancakes, right? And the next pancake off the griddle goes on top. Then the next pancake goes on top and on top and on top and on top and on top. And then you take this pile of pancakes to the table and everyone takes the pancakes off the top, right? And eventually everyone takes the pancakes off the top, and eventually the first pancake that was put into the stack is the last one out, right? That's all a stack is. A stack is the idea that you have made a bunch of pancakes. The first pancake in the stack is always going to be the last one out because you have all these other ones piled on top of it. So Q, first in, first out, right? Stack, last in, first out. So the pancake that's on the top, it was the last one on the stack. It's the first one out. So a stack is similar to how Magic the Gathering cards resolve. Exactly. The thing is that like stacks and queues we use in life all the time. Like it's not like a data structure that you're not aware of. You use them all the time. If you stand in line, you use queues, right? If you've made pancakes and you're not a monster, you've used stacks, all right? And so there are ways that we're organizing not only data, but life. Cool. So data structures you're going to see everywhere, all right? So now next time you're in line, I want you to think of me. Next time you're in line, I'm standing in a queue. Thank you, Leon. I'm standing in a queue. I'm living in that head rent free. Whenever you're in line, you got to think of me. It reminds me of the Dane Cook joke. That was like, remember when Dane Cook was like the rage? There's a Dane Cook joke where he runs up to a kid and he like smacks the ice cream cone out of the kid's hand and says, "Remember me forever." This is my remember me forever moment. Whenever you're standing in a queue, you got to think of me. All right. So queues and stacks, they're not new. We use them all the time. Here's a stack example. We push 2 into the stack. We push 5 into the stack. So 5 is the last thing in the stack, and we're going to pop 5 off. So 5 was the last thing in, and it's the first thing off. So we can use stacks pretty easily when we use arrays. Forgotten proxy, unless you have VIP, you do not have the ability to paste links. They'll get filtered out. Cool. Let's get back to getting got. We now know about stacks. We know about queues. Let's get got. So we saw some code that was weird. We saw that when there was a set timeout, all right, when there was a set timeout, it did not run synchronously. The first house was hit, then the third house was hit, and then the second one was, even though there was no delay on the set timeout, it was 0, it still had that delay in our code. So we got to figure out why. All right. And so we're going to talk about some topics now that are important to understand. I'm going to give you an overview of them. There are some nuances to be had here. So give me some little bit of wiggle room, a little bit of leeway here. Siona, hey, thank you for the 100 bits. I'm sorry, just seeing that now. Siona, throwing some appreciation back your way. Appreciate you and hope you have a wonderful stream. Show love 100. Hey, thank you so much. Thank you for the 100 bits. Sorry, I just saw that now. All right. Something we have to remember is that our JavaScript is running in the browser. We cannot forget this. Right now, the hosting environment or the runtime environment is being located in the browser. Dragonoid, thank you for the hydration. Cheers to you. Will nerds be angry? Some nerds are going to be angry about this bit right here. That's because JavaScript's kind of weird. And a lot of these terms mean something slightly different in other languages. And so if JavaScript isn't like your playground, then some of these things are a little weird. All right. JavaScript is running in the browser. JavaScript, does a computer understand JavaScript, chat? Does our computer actually understand JavaScript? Nah, not directly. What do we need so that our computer can understand JavaScript? So that we can parse our code and have runnable commands? What do we need? Yeah. We need some sort of compiler, right? Something that can take the code that we understand as like human developers and break it down into something that the computers can actually understand. And the compiler, and I'm going to use these air quotes right now, that we're using is the V8 engine. And the reason I use these air quotes is because V8 is not technically a compiler. It is an engine. It's an engine, which means it not only has the compiler-like stuff, but it also has all these other goodies like memory management and garbage collecting and all these other things that a traditional compiler just wouldn't have. So when we are running JavaScript in the browser, we get access, if we're running in Chrome, we get access to the V8 engine. That V8 engine can break down our code into something the computer can understand, but also help us with a bunch of other goodies, like memory management, like where do our variables get stored, right? Like memory management, garbage collection, all this other fun stuff. So we wouldn't call it a straight compiler. We're going to call it an engine. Okay? Whew, stay with me. Anybody know what the engine is that we use in Firefox? Or used? Oh. Yeah, Destroyer, Spider Monkey, nice. So if you're running JavaScript in different browsers, there's different engines that are kind of breaking apart your code. So in Chrome and Chrome-like browsers, you're getting the V8 engine. If you're in Firefox, you're using Spider Monkey. Cool. Now, the other thing that we're worried about is our JavaScript is running in an environment, and the environment which we are running our code, our JavaScript right now, is the browser. This environment, or we call it the window runtime, it's just the environment. This environment gives us access to all the web APIs that we've seen so far. We saw set timeout, we saw the DOM, all that fun stuff. But the environment can also do things like pass stuff onto other goodies that the browser comes with. Okay? Can come with all the other goodies that the browser comes with. So the browser not only comes with the V8 engine to like break down our code into something the computer can understand. Not only does it come with all this access to these wonderful web APIs that do all of this like heavy lifting for us, all the asynchronous stuff, because JavaScript is would block, it's synchronous, right? Like all the stuff that we need to do asynchronous stuff comes from the web APIs. But we also get all these other things, like the ability to pass off stuff to libevent. Libevent is code that's running in the browser that handles something called the event loop. Okay. Now, when we get to Node, it's a slightly different thing that's running the event loop. But right now, since we're running it in the browser, I'm going to pretend that we're talking about Chrome. So we're talking about the V8 engine. And we're going to talk about the hosting environment that includes not only all those web APIs, but also like these other goodies that enable us to run our code. You thought we were just running JavaScript. For years, I thought I was just running JavaScript. No. When I was running my code, I was running JavaScript that was being broken down by the engine, that was using code that the browser gave me via web APIs, that was then passing stuff off to these other libraries and things that were keeping track of where I was at in my code. What? So yeah. Gone are the days. Gone are the days where you thought you were just dealing with JavaScript. There's so much more happening underneath the hood that you now know. All right. Okay. That you now know. Cool. So I mentioned this event loop thing. let me throw one of these big words out here. Don't treat it as disrespect. The event loop monitors the callback queue and job queue and decides what needs to be pushed onto the call stack. Let me say that one more time. The event loop monitors the callback queue and the job queue and decide what needs to be pushed onto the call stack. Now, remember, we said this event loop is, since we're running our JavaScript in the browser's handing some task off to this lib event thing. And you can always tell how serious a project is based on its website. You know this website's doing, this is doing some shit. You know this is doing some stuff. Look at this website. You know this is serious. You know this is some serious stuff. Look at this. I don't even think I should be here. I feel like I just should be on this website. Look at this. You know this is some serious stuff that's happening underneath the hood. Like if we just ended it right here, you're like, all right, that event loop is doing some serious stuff. Here's what it's doing. All right. It's actually surprisingly like just a while loop. That's somebody's gonna send me a DM, but like it's just a loop basically, right? Like it's a loop, but there's some weird stuff going on. The loop is technically monitoring the callback queue and the job queue and deciding what needs to be pushed onto the call stack. Okay, so let's actually see what the heck these things are. Now, this example is an example I came to myself because it's the example that we ran into when I was doing the newspaper code. But the way that I'm going to step through it is definitely coming from Philip Roberts. Philip Roberts was the first person to do this. They have an amazing video that walks through this in way more detail that is actually assigned for homework. So this is not something that like is Leon original. I want to be very clear that Philip Roberts has done something very similar, and this is where the inspiration is coming from to like walk through it in this way. Okay, I want to be clear on that. It is your homework. You must watch it. Everyone here must watch that video. It is that important. But I want to talk about these things, and so we're going to talk about them in kind of the same way, and then the video will hopefully fill in the gaps and reinforce what you need to know. Alrighty, so we have our JavaScript, and JavaScript is synchronous. It is single-threaded, and since it is single-threaded, it can only do what, chat? Since JavaScript is single-threaded, what can it do? One thing at a time. Exactly. Since JavaScript is single-threaded, it can only do one thing at a time. Now, we know that we are not doing one thing at a time when we're writing our JavaScript. How are we able to do more than one thing at a time when it comes to JavaScript? How are we able to do stuff that's asynchronous? How are we able to do set timeouts? How are we able to do everything? Yeah. It's not JavaScript that has these parallel processing or these multi-threads. It's the browser. The browser gives us the ability to kind of run these web APIs, what you could think of as like other threads. JavaScript has one. JavaScript has the call stack. This is our single thread. That's it. That's all we get with JavaScript, right? Now, we know that since we're running our JavaScript in the browser, we also get access to all the web APIs. And we can consider all those web APIs like other threads that are doing other stuff, asynchronously doing fun stuff, okay? So the beauty that we're going to see here is that we can use the single-threaded nature of JavaScript, but lean heavily on the web APIs. And the thing we talked about earlier, right? The thing we talked about earlier is that eventually the web APIs, all that asynchronous stuff, eventually something happens. What happens eventually with all this asynchronous, all this asynchronous stuff that's happening in the browser? What eventually happens? Look at all these slides. There we go. What eventually happens? They get resolved, right? The promises resolve, right? And when the promises resolve, what do we need to do? We need to know, right? How do we know that the promise has resolved and we can get that information back? Like, how do we get that information? Like, we're single threaded, right? And our web APIs are doing all that asynchronous stuff, but eventually it finishes and we need that information back. Well, this is where the event loop comes in. The event loop enables us to do our single thread, but eventually figure out when we have new information that should be put onto the thread. Okay? So we're going to step through it. All right. The very first thing that we're going to do is we have our code here. So we have this console log. Then we expect the set timeout to run. And then we expect the last console log to run. So let's step through what's going to happen. Since JavaScript is going to run, we have this like main function that like runs our JavaScript. So this main function is going to run our JavaScript, gets put on the call stack, meaning like the single thread that we have that's keeping track of what our JavaScript is doing. Okay. And like I said, give me some liberties here. We're not going to hit everything in this very simple demonstration, but give me some liberties here. All right. So we've started off our JavaScript. That console log runs. So right now, the console log is on the call stack, right? We go through our loop and the console log is on the call stack. And since it is the last in, and it is a stack, since it is the last in and it's on a stack, what is it also? It is the last in, so it's going to be the what? First out. So since it is the last in and we're in a stack, it's going to be the first out, and we wind up with it being executed, and we see the console log in the console. Okay? Then we run again, and now the set timeout has run, right? We do our loop. The set timeout has run. So since the set timeout has run, what do we have to do? If we're running a set timeout, what are we really running? Is it JavaScript or what is it? The set timeout is the last in, so it's definitely the first out. Exactly. It has to get handed off to the web APIs. So now the web APIs are going to start doing their thing. That set timeout could take forever. That set timeout's going to handle it. It's going to handle it, right? Set timeout's doing its thing. It's doing its thing. And we do another rotation. Right? We do another rotation. Since the set timeout was doing its thing, we moved on to the next line of code. So now log house 3 is the last in on our stack. So it is going to be what? Log house 3 is the last in on our stack. So it's going to be what? First out. Exactly. And so we can see in the console, house 1 was console logged. House 3 was console logged. But what we did notice is that this web API had finished. This web API had finished. And when the web API had finished, it pushed the value or its callback to this new queue, to a queue. So the web API did its thing. It did its thing. And once it was done doing its thing, it sent the response, right, to this queue. And there's technically two queues. There's a task queue and a job queue. Like promises go to a different queue than then there's like macro and micro tasks. We don't have to go that deep. Just know that there's a queue, right? There's a queue. And so what we do is the event loop runs again. But the event loop sees that the stack is what? The loop sees that the stack is what? The stack is what right now? The stack is empty. So what do you think we do, chat? What do you think we do? If the stack is empty, what do we do? If the stack is empty, what do you think we do? Yeah. We take whatever's first in the queue and put it on the stack. Right? A queue, since this is the first thing in, we're talking about a queue now, since this set timeout response is the first thing into a queue, it is also the what, chat? If it's the first thing in, it is the first out. Think about standing in line. If you're the first in line, you're the first thing out. So in a real world example, we could have a bunch of web APIs that were all running. We could have fetches, we could have set timeouts, we could have set intervals, we could have all of these asynchronous things that were happening. And as they all finished, where do they get put into? Where do they get put into? As all the web APIs resolve, where do they get put into? They get put into the queue. Exactly. They get put into this queue. And as the event loop comes around and notices that the stack is empty, it takes the first thing out of the queue and puts it on the stack. We back that stack up. Cool. So now the value that came back from that promise, or the value that came, like the callback that was fired from what was originally a web API, right? That resolved, it got put in the queue. And then the queue, once the stack was empty, we put that stuff on the stack. Now the event loop comes around. It sees that there's something on the stack. It executes it. And that's how we wind up with console log house 1, then console log house 3, and then console log house 2. So even though our set timeout had 0 seconds of delay, that set timeout had to go be handled by the web APIs. And when the web API resolved, it had to go into the queue. And only once the call stack was empty did we take something out of the queue to go into the stack. That's some big stuff right there. Sour Dev, thank you for the hydration. Cheers to you. That was a big one. My brain is melting. Rezo, thank you for the hydration. Cheers to you. Exotic Male Escort said, what if there is more than one task queue? Well, there's not. The hosting environment that we're running our JavaScript in really only has 2 queues. It has a task queue and a job queue. And the event loop knows which one to check first. So basically, the event loop is going to check those 2 different queues when the stack is empty and pull the appropriate stuff out. So there's a lot there. Don't go too deep on that topic, just because you could like spend your whole career on like this stuff right here. So the await tool waits on the API and task queue to finish if they are used. Yeah. So the idea is eventually like our stuff from the web APIs finishes, it gets put in the queue, and that callback or the resolution of the promise and all that fun stuff eventually gets placed on the stack. The cool thing is that the task queue is the older thing. The task queue is what we had before ES6. Before ES6, we just had, I believe, and I might be off on my dates here. We just had the task queue. And then when we had promises, we needed like a different queue for the resolution of the promises. And so we have like a job queue as well now. Don't hold me to that, but like that's the idea. What happens if the stack never gets empty? Then nothing ever comes out of the queue, because JavaScript is JavaScript is synchronous. So let's take that idea. It's a really wonderful question. What if the call stack never empties? What if there were 1 million console logs here? Let's say there's 1 billion console logs. Let's run it back. That's a fabulous question. I love that question. I'm going to run it back. Hold on. We're going to run it back. All right. Here we are at the beginning of our code, right? JavaScript runs. the very first thing that goes onto the stack is this original console log. So now we have this console log on the stack. The event loop runs. We see that it's on the stack. Since console log is the last in, it's the first out. And we see that console log show up in the console. Cool. Now, the next line of code runs. And we see that we now have the set timeout function on the call stack. What that does is we eventually hand that off to the web API. So now the web API is going to do its thing, right? The web API is going to do its thing. We know that this web API finishes really quickly because there's no delay, right? There's no delay. But while it's doing its thing, this next line immediately runs. So this next console log runs, and what we wind up having is as the web API is finishing and pushing the result to the queue, right? As the web API is finishing and pushing the result to the queue, we already have a new console log that's on the stack. And if we had a billion console logs, right? And we kept adding them to stack, this would take forever for it to come out the queue. So all of that code, all that procedural code that's on the stack, right? All that code that's on the stack would run before this queue ever popped. And only once the call stack is finally empty, right? Only once the call stack is finally empty do we see that callback or resolution make it onto the call stack. The event loop runs and eventually triggers that callback, and we wind up seeing it go to the console. Cool. So this is where the meat and potatoes is happening underneath the hood. This is what JavaScript's doing all day. Well, not JavaScript. The runtime environment or the hosting environment that is the browser enables all this stuff to happen, right? Because because the event loop monitors the callback queue, right? So that's and the job queue, and decides what needs to be pushed to the call stack. So all the event loop is doing is just making sure its stuff isn't going here. If there's stuff here, eventually it makes it onto the call stack. JavaScript's already good at putting stuff on the stack. That's what it does. It's single threaded. It does that all day long. But this event loop thingy is checking to make sure we don't have anything on this queue because we'll need to eventually put it on the stack. That's it. Now you know how now you know more about JavaScript and how it runs underneath the hood than I guarantee you at least 10% of developers that are writing JavaScript right now. I will go out on a limb and say that if you can master this concept or at least understand, have been following along with this, and you understand that like JavaScript is being broken down by the V8 engine, that these complicated things are being handled off the web APIs. This event loop is like taking stuff that comes from the results of those web APIs, eventually puts in the stack. If you can do that, I guarantee you understand more about JavaScript and its hosting environments than like 10% of developers like actively being paid to write code right now that are writing in JavaScript. So, if this is tricky, as it should be if it's the first time you're going through this, on Sunday, we're going to go through this again with more details, with more examples so you can get a better hang of it. But you're also going to watch Philip Roberts' amazing video that goes even deeper. And then you're going to watch Jake Archibald's video, which goes into the event loop thing even more detail. Rockefeller nerd, test them. The videos are linked in the slides, and they are also in the follow along materials channel from today. So both in the slides and in the follow along materials channel on Discord, they have been linked. All right, time for some backend, baby. All right. Now, the cool thing is everything we just learned about how JavaScript runs in the browser can also be applied, right? Can also be applied to how JavaScript runs via Node. So we get to use all the same concepts over again, just with some slight tweaks. Yeah, the Node is called a runtime environment because it's JavaScript and all the stuff JavaScript needs to do its job. Because JavaScript by itself doesn't have the ability to do all that stuff. Node has all these other goodies that enable JavaScript to do all the heavy lifting. Ooh, Terabizi with the posture check. Let me get in here. Let me get this posture check going on. Ooh. Node refers to what? Hold on, baby. Hold on. I got you, fam. I got you. Hold on. We're getting there. What does node mean? I got you. Hold on. All right. Let's talk about backend. All right. Here's a question. I want chat to erupt in this answer. Does JavaScript have access to the DOM natively built in? No. Nope. Doesn't. JavaScript needed web APIs provided by the browser to handle all that asynchronous stuff, all the stuff that we just saw, that event loop stuff, the asynchronous stuff, all that was provided to JavaScript because JavaScript was running in a browser. JavaScript did not have access to any of that stuff. Like the language itself does not have access to any of that. It's because we were running JavaScript in the browser that we got access to it. JavaScript is a language that can only do what the hosting environment allows. So if the hosting environment, like the browser, didn't have access to web APIs, we couldn't interact with the DOM. We couldn't do anything asynchronously. JavaScript is still single-threaded at the end of the day. Now, the cool thing is we're approaching a different concern now. We don't want our code to run in the browser. We want our code to be able to run on a server or maybe the desktop or other environments. And so we got to start thinking about what does the server need. And we talked last class about a server needing really two things. Server needs disk access and network access. Remember, when we type dominoes.com into our browsers, the server hears that request and generates a response. The reason why dominoes.com can hear our request is because it has access to the network. And the reason why it can send us those beautiful looking HTML, CSS, and JavaScript files is because it has access to reading a hard drive or an SSD, etc. Now, JavaScript itself does not have the ability to read files. JavaScript itself does not have access to the network. None. It has no way to get files. Like if you just have JavaScript, you can't get access to files on your computer. Right? That's really good. It's good that JavaScript is sandboxed in that way because we wouldn't want to like go to a website and then be able to like look in our special folders with our special images in them, right? We don't want that to happen. But when we're building servers, our servers need to be able to get files because we want to send files to people. Like if they come to our website, we want to send them specific files. Old coder trick. Ooh, I didn't see that one. Old coder trick got a stretch in. Hold on, let me get a stretch in real quick. Hold on. BRB. Burb. Oh, baby. Not that kind of stream, folks. You don't get to see this. Ooh, OnlyFans content. Oh, yeah. Cool. Kayla. Blah, I think they're on a walk right now. Alrighty. So, JavaScript doesn't have access to the disk. JavaScript doesn't have access to the network. What if there was a hosting environment that enabled JavaScript to have access to the disk, access to the network, so that we can build servers, we could build desktop apps, we could build other types of apps too? What if there was a hosting environment that allowed us to have that? 10-second warning, of course. Well, we do. We do have that hosting environment. It's Node, baby. It's Node. It's Node. It's Node. Hey. Yeah, that's it. Feel the vibe. Somebody mentioned it last class, but like the song was dropping right as the beat dropped for her as well. All right. So we know that Node is a hosting environment that's going to give us access to things like disk and network. The cool thing is you go to the website, you download Node, and you see this. Node is a JavaScript runtime built on V8's JavaScript engine. We should have a really good idea of what this gobbledygook actually means right now. A runtime. A runtime is just a hosting environment. It's like the place where we're running our code, right? So Node gives a place to run your code, right? To run your JavaScript. And it has access to, like in that environment, that place where you're running your code, it has access to the V8 engine. So once again, we can use that V8 engine, right? We can use that V8 engine again to compile our JavaScript and get access to all that other good stuff. The memory management, the garbage collecting, all that fun stuff that's not traditionally just the compiler. We get that also on Node, right? Now, the interesting thing is that that was the example from last time. the interesting thing is that all the stuff that we got, all those goodies, right? They're just little tweaks to it. And so I always laugh when I read these things for the first time, but I feel like hopefully now you feel a little bit more comfortable with these words. Chat, can you give me a micro Leon or a yes if this kind of makes sense now? Does this kind of make sense, just so I know where I'm at? Cool. Keeping an eye. All right, so we're on the way. We're on our way. All right. I always, whenever I see these, whenever I'm learning a new language, and I have to tell you this, like this is every day, like this is all the time for me. Whenever I use a new language, a new framework, a new tool, they always do this, and I always do this. Like what the heck? And this leads me down like a chain of like research, and so you shouldn't feel uncomfortable. Like, well, yeah, you should feel uncomfortable because they're. I don't understand why they just can't explain it in plain language, but through research and trial, you should be able to start figuring out some of these terms. And that's what I do. Whenever I do something new and I'm like, what the heck? I spend time Google researching, Stack Overflowing, Redditing, trying to figure out what it is. I talk to other engineers to try and figure out what it is. And so you got to get used to that process for yourself. All we meant by that, like runtime and V8 engine, is just the same stuff that let you run JS in the browser can now be used to run JS on servers, desktops, and elsewhere. V8 is still doing all of the heavy lifting, and we talked very briefly about this, but I keep saying V8 engine and not compiler. What is the difference between an engine and a compiler, chat? What is the difference between an engine and a compiler? Engine and a compiler. Ooh, there we go. We got some folks in here. An engine includes like a compiler, but also a bunch of other stuff. So V8 is not just the compiler. It's also doing memory management. It's doing garbage collecting. It's doing all these other really important stuff that we're going to need. So it's doing more than just breaking our code down into small, easy to read pieces that the computer can understand, right? Remember, we're talking about like why Independence Day is a true story, right? Binary upload boom. Jeff Goldblum was able to write a computer program that they reverse engineered all the way down to like binary and simple logic and built all the way back up. Well, what V8 engine is doing is taking our JavaScript that we understand as humans writing the code, it breaks that down into something that the computer can understand. But it's not just that step of breaking stuff down. It's not just that step of breaking stuff down. It's also the step of doing all these other tasks for us as well. Just like the browser did all these other tasks for us as well, all those tasks are happening for us in Node as well. So just like the browser came with all those web APIs, Node comes with a bunch of stuff too. All right. comes with a bunch of stuff too. Node comes with built-in modules, which are just collections of functions, just a list of functions, basically. The ones that we saw last class were HTTP and FS. These are just modules that give us access to network and access to the file system. Remember, JavaScript does not have access to these two things. Through the Node runtime, it gets access to require, which means that we can ask for these modules. Right? We can get access to these modules since we're running our JavaScript in the Node environment. And we also get access to millions of other packages, which are just basically like one or groupings of other custom modules that people have written. I think we're almost at like 2 million packages on NPM right now. Cool. Now, the interesting thing, there's one slight caveat here when we're dealing with Node. Instead of, we still have all the same stuff. We still have like the event loop and all this other fun stuff, but it's slightly different. In Node, we don't have the browser's web APIs. We have C++ APIs. We have C and C++ APIs. So instead of getting all of the browser APIs like the DOM and stuff, we get access to some APIs that come from C and C++. Okay? So we get the idea that JavaScript is running in the Node environment or the Node runtime. Like it's JavaScript running in like this container, right? And that container gives us access, gives JavaScript access to the V8 engine. It gives it access to async stuff. So where we used to use web APIs, we're going to use libov, which is like a C, C++ library. And we also get an implementation of the event loop. All of that comes because we're running JavaScript in the Node environment. If we weren't running JavaScript in the Node environment, we do not get any of this stuff. We do not get any of this stuff. Just like we didn't get access to all that stuff without the web APIs, if you are running JavaScript without Node, you don't get access to this stuff. Okay? But it's the same thing. It's basically just slightly different variations of all the things we had in the browser. We had libevent in the browser. We have libof in the in Node. The event loop was handled by that libevent. The event loop is handled by libof here in Node. So it's the same stuff. Cross connections, open connections. Alrighty. So with Firefox, the only thing that would change would be its engine. Yeah. You're not using the V8 engine in Firefox, you're using SpiderMonkey. Yeah, I like that, Gray Turtle. Node equals JavaScript plus C/C++ APIs. Yeah, that's all it is. You're taking JavaScript, you're giving it access to all these APIs so that it can do the stuff that a single threaded language cannot do. Just like in the browser, our JavaScript cannot do asynchronous stuff without web APIs. Same thing in Node. Without access to these libraries, we can't do the asynchronous stuff that we're used to. All right, so I asked you to install Node. We talked about how there are different releases of Node. We're using the LTS because it's going to be supported for a long time. And we started looking at a simple Node server. So what I want to do is I want to take a break. Because we're at the top of the hour. We're going to come back. We're going to look at 2 pieces of code, and then we're jumping over to Remo. So let's go ahead. Let's take our 5-minute break. Kudos to you for putting in the work this evening. I know this stuff is difficult the first time through. 5 minutes on the clock, folks. And we're going to put some break music on. I'm not going to run ads just because we're not going to be on here that much longer. Remo is our classroom. It's where we can work together in groups. Why didn't they choose a language that could have multiple threads for web development? Come back next week. We're going to talk about why all this makes like JavaScript and Node really, really powerful and useful. Multi-threading comes with a lot of headaches. It comes with a lot of complexity. It comes with a lot of things that you have to manage. Node and JavaScript simplifies all that. MacTay, how's the machine doing? They're doing really well. Yeah, they're acclimating well. tried downloading Node and your antivirus went berserk. That's wild. How many more weeks of bootcamp? We're going to like end of May. End of May is our stated end time. How to get the Remo link? It's in the slides. When we get to that point, it'll be there, and I'll also share it in chat. Actually, I got to update the Classroom link today. We should be able to do exclamation point Classroom, but I didn't do that. Let me do that now. Hope you're having some fun. Hope this stuff wasn't too mind breaking. But I'm telling you, if you're getting this stuff, you're leagues ahead of folks. All right, I updated. Oh, let me update the Classroom link here. Please take a break. Please get up, walk around, hydrate. All right, Classroom has been updated. You can do exclamation point Classroom to get access to it, but we're not going to be there yet. Exotic, yeah, that's my goal. Is that you have everything that you need, but the thing we talk about here all the time, the skills aren't enough. The skills aren't the thing that gets people jobs. It's the networking that we do. It is the recommendations to the jobs that we get. So we really focus on that towards the end of the program. The back hurts? Exactly. I think we're going to run it back. We're going to do it all again. I do get what you're saying, but I can't imagine writing anything at this point. Exactly. That's why we practice. We're not there yet. We got to understand the concepts first. So when we start writing it, we're good. XD, just found out about this channel today. Is it still possible to catch up? It is the best time to catch up. We just did a catch-up class last Sunday. You can catch the VOD here on my channel. It's a 6 hours and 40 minutes of review. Have fun. Use that as your review, and then catch up with last class, and you're good. You're there. You're with us. Exclamation point 100 devs has everything you need to know. We do have to update it with that new link, but yeah. Lewis, we're going to get to that when we come back, but FS is the file system module. It's what gives us access to files via Node. All right, folks, you got a minute and a half left. Please grab some water, stretch, give your eyes a break, look outside in the distance. Boom. What is the 100 hours project? It's a project you're going to sink 100 hours into because learning in class sucks. Yeah, we learn. We get some concepts, but it's not how you learn to code. You learn to code through building. And so your 100 hours project is where you're going to learn the most. Honestly, like as the person that's sitting here trying to teach you, you're going to learn way more from doing your 100 hours projects than you do from listening to me. Blah wireframe, super simple. I played 70 hours of the Final Fantasy VII remake. Yeah, so if you can put 70 hours in Final Fantasy, you can put 100 hours into a project for your career, right? What does API mean from backend point of view? So an API is just a simple interface for something complex. So something simple that you can access that gives you some really complex things. And the complex stuff is like abstracted from your view. You don't really see it. So when you talk about like going to a restaurant, you use the menu, you select what you want off the menu, and you get some really complex dish back. You don't know how the chefs cut the vegetables. You don't know how they stir-fried everything. You just said pad thai, and you got a wonderful dish back. So that's what an API is. Now, APIs are used everywhere. When it comes to Node, we're using C and C++ APIs to do stuff that JavaScript doesn't come with. When we were running our JavaScript in the browser, we were using web APIs to get access to the DOM and stuff that JavaScript doesn't come with. So we got these very simple ways to interact with some really serious software that we don't really have to understand. We can just consume and use. Now, when it comes to web development, there are also something called web APIs, which are a little bit different, and we're going to get to those next week. That's what we're covering, how to build web APIs next week. All right, folks, come on back. Come on back. I'm going to chill the music here. So Node just runs on the server, and V8 is sandbox on client, and with JS connecting both. So you have the V8 engine running in the browser, and you have the V8 engine running on Node. So if you are building both, client-side and server-side, your client-side JavaScript is running in the browser, your server-side JavaScript is running via the environment that is Node. So on both ends. Alrighty, folks, come on back. All right, last class, we saw some really simple ways to build a server. So here's like what I think the most simple server that you can build. You have a lovely requiring of HTTP, which is the module that handles listening to requests. And we also have the FS module, which is the module that enables you to have access to the file system. We then called a method on that module, which let us know that HTTP is really just an object. So this requiring is going and getting an object that just has a bunch of functions inside of it. That's all we're doing. We're getting an object that has a bunch of functions inside of it. One of those functions is create server. So we're able to create a server on the port 8000. All this server does is listens, and when it hears somebody requesting something, it sends this HTML file that's stored on our hard drive. Right? That's stored on our hard drive. So let's go ahead and fire that up. I'm going to close these two. I'm going to go ahead and open it up. We've seen all this last class. Let's go a little bit faster. We see that the HTML file is here. We have the hello world. We have our demo.js. I have Node installed. So I am going to, oh no, it's smaller. Got to figure out how to make that persistent. All right, so I am just going to go ahead and run this file. So I'm going to cd into my Node intro folder. And I am going to go ahead and just run node and demo.js. Cool. I know it's really tiny. I'll fix that later. I did not get my prompt back, so I know what. Yeah, it's working. The server's running. I know it's live. I didn't get my prompt back. So if I go to localhost, and I go to 8000, I get that lovely hello world. Right? So it worked. My server heard my request, and it responded with some HTML. Okay? Heard my request and responded with some HTML. So I'm going to go ahead and chill this server here. And the way I chill it is I'm just going to do Control-C, and I get my prompt back. And as soon as I have my prompt back, I know what? Yep, that the server is no longer running. Telescope says, right, so right now the computer is your server. Yes, right now my node is running on my computer, so my server is running on my computer. Eventually, we're going to run our node code on somebody else's computer. And the reason we're going to run our code on somebody else's computer is because when we're done class, I'm closing my laptop and you all wouldn't be able to access that anymore. So we're eventually going to put all of our code on somebody else's machine so that it's always connected to the internet, so that it's always running, and I don't have to worry about keeping it up on my actual laptop. Cool. Heroku is what we're going to be using a lot of, yeah. You've been served. All right. Now, we have a slightly more complicated version. We're also all software. We're all full stack web application builders now. What did I just say? We're all software engineers already, but now we can build full stack web applications, right? So that's the beauty. Once you get this code running, you are now a full stack web developer, right? You're a software engineer with full stack web development skills. You can build backends and front ends. All right. Let's look at a slightly more complex backend. Look at it. Look at this slightly more complex backend. Not this one. Sorry. This one. So if we look at this node backend simple, I'm going to go ahead and open up the server.js. And let's go ahead and run this. Let's go ahead and take a look. I'm just going to run this one. I'm going to go out of this folder. I'm going to go into my node backend simple folder. And once again, I'm just going to do node server.js and let it run. Now I'm going to go back to the browser. I'm going to go back to my localhost. And you can see I got something slightly different this time. I'm serving up different HTML now. I have other pages I can go to now as well. So not just the root or the main route here. I can do other page. Boom. Look at me serving up another HTML page. You want to see it again? Want to see another page that I'm serving up here? Look at this. Other page. Then DJ Khaled, another one. Other page. So we got other page as well. Let's go back to the main page. Let's go back to the main route here. Just the nice little localhost 8000. Let's enter somebody's name in here. Let's enter in John. Do you all know who John is yet? John is Bob's evil twin. John is Bob's evil twin. So we're going to enter in John. We get unknown, unknown, unknown. They don't know who John is. Right? Let's put in Leon. Let's click it. Oh, Leon, boss man, baller. Thank you. So this is working. This is working. The lore on this stream is getting to be too much. All right. So the cool thing is we got a lot of stuff happening here. No longer we just constrained to one page, but we got some. Is that client-side JavaScript that was making fetches that I saw? Yes, it was. I have my own API running here, folks. I built my own API here. Let's take a look at what we got here. All right. HTTP we know gives us access to the network. FS gives us access to the file system. But we got some other ones here. We got URL, which is going to enable us to look at our URLs. Right? It's not rocket surgery. The URL is going to enable us to look at what's up here. Right? That's pretty cool. We also saw something else there called Figlet. Let me try requesting a page that doesn't exist. That doesn't exist. Oh, I got a 404. But that 404 looks fancy. I didn't code that. That came from another package from NPM via Node. All right. So we're going to take a look at this. We also have query string. Query string just enables us to look at query parameters. Cool. And then here we have, it looks like a whole hot mess. And it is a whole hot mess. Right? Because what this is a very, very simple web server. It's very simple. What it is we are setting up using the HTTP module, the create server, and then every single thing is inside of the server that we just created. So all of that code is inside that server, right? And then the last thing we do is we listen for that server on localhost 8000. So we set up our server and we listen to it. Now, if we look inside this server, we have the ability to see what path we are on. We're able to look at the URL. And if I type in other page, we're able to grab what page we are on, right? We're able to grab this other page from the URL. If we look at our server that's running, like if I open up my terminal and I go to where this server is running, you can see I have a list of everything that's being requested. I have a list of everything that's being requested here. Right? I have a list of everything that's being requested here. And the cool thing, let me move this over a little bit. The cool thing is that every single time I make a new request, I'm seeing it. And the reason I'm able to see that request is because I am console logging the page. So as I'm making these requests, as they're coming in, as I'm going to different pages, like I'm opening up the HTML, I'm going to these different pages, all these requests are coming through. So when I type in other page, I have made a request. When I type in other page, I have made a new request. I can see those requests being logged because of the console log. Cool. Now, so somebody said, why is parse? Because it's deprecated. It's old. We might not be using it going forward, but this is really, really simple. And I think having it this simple is important. So I like to use a lot of weird things when I first introduced Node because I think this is slightly more readable from the very, very basics. Now, the cool thing is, for each request I make, if I type in localhost 8000, I am making a request to this path, this lovely /. And so if I just go to localhost 8000, what I am going to serve up is my index.html. I am going to go to my hard drive. I'm going to find this index.html, and I'm going to serve it up. So when I go to localhost 8000, and I type in localhost 8000, and I hit enter, I have made a request. I have made a request. My server heard that request in chat. What did my server respond with? My server heard that request at localhost 8000. What did it hear? It heard that request, and what did it do? What did my server do when it heard that request? What did it respond with? Yeah, it responded with a file. I hit localhost 8000, and it responded with a file. If I go to any website, I can't type in Domino's, so we got to use something else. I can go to Pokemon.com. When I typed in Pokemon.com, they heard that request and they responded with files. This is day one stuff, folks. When we make requests to servers, servers serve. They serve up files, right? So that's what we're building here. We're building a server that can hear a request and serve up those files. So right now, when I make a request to localhost 8000, this is the route. It's that /. I'm going to serve up my index.html. Now, here's a really odd thing. Once this index.html renders, what does it do? What does it do? Well, it's going to make other requests. Look, it's going to ask for the style sheet. It's going to ask for your JavaScript file. It's going to make more requests. And so our server has to be set up to handle those requests. So if we go back and look at our server.js, we're going to scroll down. All right, here's the other page. If they go to localhost 8000/other page, we got them. If they go to localhost 8000 other page, we got them. If we go to this API thing, we got them. Hold on, we're going to come back to that. And if they ask for css.style.css, we send them the CSS file. If they ask for a JavaScript file, we send them this JavaScript file. And if they mess up and they request something that's not the main route, the other page, the other page, or the style sheet or the JavaScript file, what runs? If it doesn't hear any of those requests, what runs? If it didn't hear any of those requests, it runs Figlet. And it's going to give us a 404. So if I go over here and I type some nonsense, we get a 404. Now, for a lot of you, this might not have worked. For a lot of you, this 404 might have broken your code if you're trying to run it right now. Why would it have worked? Why would it have not have worked? Why might this Figlet not work for you? Does Figlet come with JavaScript? Does JavaScript have access to Figlet? We got to get it. We got to get that package. We got to get it. So the way we get it is wherever your folder is. So I'm going to kill my server here. Wherever your folder is, you're going to do npm install Figlet. npm install Figlet. You hit enter, and it's going to install Figlet for you. Then you have access to it. Eventually, we'll do all this stuff automatically with certain files that do this for us. But right now, you can just do npm install Figlet, and you would have access to Figlet. What do you mean where your folder is? Wherever your server.js file is, put it there. You can install packages globally, but let's not worry about that for right now. So wherever your server.js file is, go into that folder and do npm install Figlet. Then you have access to Figlet. And you could do that for any other package that you would want. Cool. All right. We could spend the next hour going through all of this live. But I want you to go through all of this together. So I want you to start picking apart line by line what you think is happening here. I want you to back that back end up and work through it together to figure out what's happening. So I want you to ask yourself, what's happening? Look at all the code. Look at it. What's it doing? We're going to go over it on Tuesday. Don't worry. We're going to come back and do it together on Tuesday. But I want you to back that back end up. I want you to look through it. What's happening? And then ask yourself, how might I clean this code up? How might I clean it up? Maybe a switch case? I don't know. Maybe you watch the videos and you know how to clean this up already. But what I would like us to do is, we got more than a half an hour left. I want us all to jump over to Remo. And on Remo, you're going to get into a group. And in that group, you are going to work through this code together. And you're going to figure out how it's working, what it's doing. You're going to share your screen. You're going to get it working. You're going to figure out how you might actually clean it up. And then for homework, I want you to build a coin flip game where the randomization happens server side. So that math.random, I want that happening server side. So you're going to get into your groups. You're going to struggle through the code together. You're going to figure out what the heck's going on. You're going to spend the next half an hour plus going through it together. Right? And then you're going to have some homework. And if things are really not working, you're going to come back on Sunday. And on Sunday, we're going to dig through it together some more. All right. So you can do !classroom and join the classroom right now. Or you can just click the link that's in the slides. And I will see you all over there. I'm going to join some tables and see if I can help too. Cool. Alrighty, folks. Hop on over to Remo. No raid, because we're going right to Remo. No raid, we're going straight to Remo. I want everyone in there. If you're working on this stuff, come work with us. If you're here, come work with us. Everyone on Remo, I'll see you over there. Let's go. We got some code to work through. Real developers work on teams. You got to learn to work in teams. You're going to get plopped into a group with some folks that you don't know. Guess what? If you want a job, that's what you're going to be doing. All right, folks. I'll see you all on Remo. Hop over right now. !classroom if you need it. Use the Remo link here in the slides if you need it. And I will see you all in the classroom. We got a half an hour left to dig through some code together. I'll see you over there.